Number 8. Number 8 is a fraction. So is it okay with you guys? Can I take you through what maybe would be a thought process you might have if you were being assessed on this? So check this out. What I'm about to do, please don't write this down unless you want to write down what would be a bad example of what to do. So you might look at this and say, hey, look, it's a fraction. And isn't it fair to say that some of the things we've done in the fraction would be to take the denominator and flip it up to the numerator? Okay, so you might do that. You might say, all right, I don't want this to be a fraction, so I'm going to do this. And when I do this, the flipping up part, I get to the negative 1, right? Make sense? Okay. And so you might then say, all right, well, we could do Timmy messed up the chain rule here, and we could look at the inside. And if you look at the inside and ask yourself, what's the derivative of the inside? Isn't the derivative of the inside the other factor? And you might tell yourself, awesome, that's what this is. The e to the x is just going to go back inside, and all I have to do is integrate that outside function. Here's where you run into problems. You would say it's going to be 1 plus e to the x to the negative 1 plus 1 over negative 1 plus 1. What's the problem here? Division by 0. This is a major problem. This is not going to be what it is. Can I give you a hint about something? And I think this hint is probably going to be true just about every time, unless you've made multiple mistakes. If you are trying to find an antiderivative of something and you find yourself about to divide by 0, you need to go back and rethink. The answer is probably going to be natural log of something. Okay? So if you ever find yourself saying divided by 0, no, that's not good. Go back and think it's probably natural log. Okay? So think it through like that. So this is the one scenario. This is going back to 5.2. This is the one scenario that you learned so far. You'll learn a couple of others. And the scenario is this. The integrand has to be a fraction. You can't flip it up. You can't simplify it. You can't divide it. You can't turn it into something that's not a fraction. It has to be a fraction to work here. And so here is your thought process. If you're going to do the Timmy messed up the chain rule version, and to me, this is the way to go. You can do U sub if you want, but this is the way to go. Look at the denominator and ask yourself one question. Is the derivative of the denominator the same thing as the numerator? And in this case, the answer to that question is, yeah, it absolutely is. And so if that's the case, then the answer has to be, the antiderivative has to be natural log of the absolute value of the denominator. Okay, so ln is not a choice. The integrand is either going to lead to ln or it's not. This one leads to ln because of the nature of what it is. All right, we're going to evaluate this from 0 to 1. And using FTC 1, we end up with natural log of 1 plus e to the first minus natural log, I guess it'd be 1 plus 1, wouldn't it? So 2. So this would be your final answer here. Since the calculator is not active, you kind of have to leave it like that. And you're done. Question, Zach?
What happens if the numerator is not here?
Okay, so let's do something like this. Let's do a slightly different question. I'll give myself a little room here. Let's say, so that's kind of a loaded question. There are many answers. I'll try to give you a couple of them. So let's say we had, and I'll forego the whole 0 to 1 thing because we're just really talking about the antiderivative, right? So let's say we had something like this. Antiderivative of e to the x over 1 plus 2 e to the x. So if you look at this and you try the whole flip up thing, and you're like, oh my gosh, division by 0 must be ln, right? So then you ask yourself, what's the derivative of the denominator? And the answer is 2e to the x. You look at the numerator, and it doesn't quite match. Timmy messed up a little bit, right? But he didn't mess up so bad that it's unfixable. All I really have to do is say times 2, and now it does exactly fit the chain rule pattern for natural log, but then I've got to adjust by doing that. Okay. So you'd end up with 1/2 natural log of 1 plus 2 e to the x, in this case plus c, if that were the question. Does that make sense? Yep. Okay. So there's other versions of this, like the thing you described, like what if the derivative of the bottom isn't the top? So check this one out. I've showed you something like this before, I think, or maybe it was slightly different. Let's say you had integral of 1 over the square root. Well, let's not do the square root. Let's just go 64 plus x squared. So definitely a fraction. And you can see that if you flipped up, you're going to get division by 0. In fact, if you flipped up, you'd actually have to say Timmy messed up by a lot more than just like a 2 or a 4 or something like that. Yeah, he messed up by an x, right? But, if you looked at this and said, yeah, the derivative of the bottom is 2x, the numerator is a 1, we're off by a 2, which is not a big deal, but the x is a huge deal. This does not lead you to ln at all. This is not a Timmy adjustment or U substitution. This leads to something else entirely. So we sometimes try to make square pegs fit in round holes. So this is just, that one right there is simply not ln. It ends up being arctangent. We'll talk about that one later. Does that make sense?
Yeah.
Okay. Cool. Any other questions? I love what if questions. I feel like usually I can answer them. They're always entertaining. Any other of those sort of questions? Okay, fair enough. Well then, let's move on to our second to last set of questions here. This is number 9. And this one is calculator active. Okay? So it says a particle moves along the x-axis such that the velocity is given by v of t. And then 2 questions, a kind of a comparison contrast scenario. Find the displacement on 2,4. Find the total distance traveled on 2,4. Calculator active, so please find a good opportunity to use that. I think this is very doable if you know how to set it up. So for example, in A, it wants to know displacement. Displacement for an object like this would be the integral from 2 to 4 of simply v of t. And if I were you, I would write it just like that because v of t was already defined to be that. So if you want to write the whole 3e to the negative t cosine t in there if you want, that's fine. But if I were you, I would just write v of t because it's been defined. You can use either name interchangeably and it's good. Then I would use the Math 9 feature on the calculator to get an approximate answer for this. What did you all get? 94.494. Yeah? Okay. So remember, for you to get credit for something like this, please listen. Both of these elements have to be in play. So if you were to not write this, if all you did was write that, you get no credit whatsoever, right? Because you're just like pulling a number out of the air. If you're going to use Math 9, you got to tell me that that's what you did. And the way that you did is by writing down the thing that has the x over it, right? You're saying, I'm going to do a definite integral, blah, blah, blah. I know the calculator's doing all the in-between details, and there's the answer. I get it, but I need to see essentially a setup and an answer. You don't even have to write, I used Math 9 or something like that. Please don't write that. If you really want to, you can. But you don't have to do that. You can just write setup, answer, and you're good. Any questions? So the other one is, of course, almost just like this. It's the integral from 2 to 4, but it's the absolute value of v of t. This, of course, takes any negative displacement that was initially present and absolute values it to be positive motion, right? Because total distance traveled is only positives. And so you plug this into the calculator as well. The calculator would take an extra 3 seconds because it has to think a little bit more. And it comes up with? Say again? 94.494. Okay, interesting. Okay, so the same number. So can anyone explain what that means about the motion of the particle? What do you think?
It's always positive.
It's always positive. So the particle never does what?
Changes direction.
Never has a change of direction. You're right. Never does, because t dt and displacement, same thing. Okay, cool. We good? Any questions? All right, so let's tackle the last one for 5-4. This is an FRQ. It's got a couple parts, obviously. You can see that. We're going to go part by part. So if you would, take a minute, read the question as is. I apologize for the little line break on the P prime that's given to you there. I'll read it out loud if you want to hear it. Listen, you can read along with me. It says the number of gallons P of T of a pollutant in a lake changes at the rate P prime of T equals 1 minus 3 to the negative 0.2 T gallons per day. T is measured in days. There are 50 gallons of pollutant in the lake at T equals 0. The lake is considered safe. This is a little alarming. When there's 40 gallons or less of pollutant in the lake. That's good. Hopefully it's a really big lake, right? 40 gallons of pollutant sounds like a lot. Okay, so we've got this scenario. There's going to be parts of this that are very applicable to like right now, but a lot of this is going to be like old applications, right? And that's good. We want to keep dragging those old applications into these newer skills. So take a look at letter A. It says, is the amount of pollutant increasing at t equals 9? And then you got to give a reason for your answer. Okay, so let's just do A. Let's make sure you complete A here. I'll give you a few minutes to do that. Then we'll review a solution. It says, is the amount of pollutant increasing? So they actually gave us a variable for this. What variable stands for amount? P of T. They said the number of gallons P of T in the lake. So it says, is the amount, so you could substitute, is P of T increasing, right? So is P of T increasing at T equals 9? How would we judge this? What would we use to tell us if P of T is increasing or not? P prime, right? Because P prime is the rate of change, and so we'd use that to help us figure out what's going on with P. So what we would do here is we'd do P prime of 9, and the fact is we already have P prime, so really all you have to do is plug in a 9 for T in that P prime equation and get an answer. So did anybody do that and get a numerical answer? 0.504?
Yep.
And that's positive?
Yep.
Okay, so 0.504. And of course, the important aspect about that number is that it is positive. And since P prime of 9 is positive, that means the amount is or is not increasing? Is, yeah. So you'd say, therefore, the amount is increasing at T equals 9. So wouldn't it be fair to say that the trick on this one, on A, is you don't actually like find any derivatives? Like the derivative that you're going to use has already been found for you. The temptation here, of course, is not recognizing that P prime is the rate that you actually want and differentiating that, like doing a math 8 or something like that. That would be a trap that would be easy to fall into. Looking at the looks on your faces, I don't think you fell into that trap much, if at all, so that's good. You guys have any questions? Super old. This came from section 3.3 in your book. Super old application. I'm glad you're remembering it okay. Take a look at B. B says, for what value of T will the number of gallons of the pollutant be at its minimum? Justify your answer. Okay. So notice it didn't ask for the minimum. I just wanted to know the time when it would be at its minimum. So again, I'll give you a few minutes here to work this one over. Check your answer in a minute. Certainly, I think I have some things to add to your conversation. You're doing a great job. Check out B here. So it says, for what value of T will the number of gallons of pollutant be at its minimum? Justify your answer. Did you notice that there was no interval given to you, right? There was no like 0 is less than or equal to T, which is less than or equal to 20. There's no time interval. And so therefore, this really can't be a absolute extreme. It's got to be relative. So to find relative extreme, I need to find critical numbers. So I'm going to set P prime of T equal to 0. Slash DNE. I think DNE is not an issue here, but equal 0 is. Guys, I want to be super clear because I feel like we're almost there with this. We're really close. If you're going to be solving an equation, P prime of T equals 0, isn't the next step to use the calculator? Right? But if you don't write this down on your paper with your hand and pencil, actually getting the ink or the lead down on the paper, you will not get credit for it. So please, if you're about to solve an equation on your calculator, make sure that that equation is clearly written down on your paper. Make sense? I hope it does. Okay, so, whoops, that's not what I wanted to do. Let me go back to that. So P prime of T equals 0. What did you all get for an answer for that equation? T equals 5 point what? 493? Okay, yep. I think I saw that on quite a few papers. So 5.493. And then, since you just graphed it to find the 0, we can look at the graph to help us use this. Hannah, what pattern did you see for P prime around that critical number? Yeah, and so that justifies it, right? Yeah. So you'd want to write that down, say something like P prime of T changes from negative to positive. We're using the first derivative test here. At T equals 5.493. Therefore, P has a minimum at that time. Does that make sense? Any questions? Okay, awesome. So then the final two questions here. C, is the lake safe? So you're going to have to do a little bit of work to figure that out. And then D, we're going back to a tangent line approximation. This is a lot of really good review of applications. So if you would, please try C, and we'll get to D as well. All right, well then how much is actually in there at that minimum point of time? Make sense? Okay. So just chatting over there with a couple folks. If we had a function for P of t, listen please, hey. If we had a function for P of t, wouldn't you just plug 5.493 in for the input and you'd get an output and that would be the amount at the minimum? But the truth is we only have an equation for P prime. We don't have an equation for P. But knowing that we have an equation for P prime and I want to know about P, what am I going to have to use? Like what tool? You have to use an integral, yeah. So if I were to do this, check this out. If I said integral from 0 to 5.493, whatever it is, of P prime of t, dt, gentlemen, I know you're doing really good stuff, just quiet down just a little bit. If I were just to do that right there, throw it into my calculator, do math 9, what would that actually tell me? Like conceptually, what would that mean?
Displacement in the...
Yeah, but we're talking about pollutant, so it's not really displacement, it's net change, yeah. So this would give you the net change of amount, and if I'm right, it's like some negative number, isn't it? So if you were going to try to use this to compare, because it's 40, isn't 40 the safe number? 40. So if you're going to compare that to 40, you have to look at that and be like, negative? What? That doesn't make any sense. What am I forgetting to use if I just did this? The 50, right? I forgot that there was 50 gallons of pollutant in there to begin with. So I'd have to go 50, which was the original, plus the change. This will give me the actual amount. And so if I use the calculator here, I end up with equals, what was it, like 45 something? 49 what? 3. Okay, fair enough. And so then we'd compare this to 40 and say, well, that's bigger than 40. Therefore, is the lake safe? No. Therefore, no. That makes sense? It's bigger than 40. Okay. You guys have any questions about that? Are you getting kind of stuck on D? I've noticed you guys have been kind of working your way through. Is D going okay? Going okay? Some struggle, some okay. All right. Well, let me give you a couple more minutes here to try to finish up D, and then we'll be done. But in typical government worker fashion, they did not get the answer they wanted with Part C, and so they decided to come up with a new way in Part D. That's kind of what's going on here, right? Part C, I mean, we knew the minimum happened at 5.493, and was the lake safe at that time? Nope. Well, we better do some different math to find when it would be safe. So I don't know about the ethics of this question. It is what it is. So here we go. It says an investigator uses, the investigator says, that curve we were using back there in parts A, B, and C, I don't like it, so I will be using a tangent line approximation to make my new judgment. So whatever. So we're supposed to find this tangent line approximation to P of t when t equals 0. So when t equals 0, I need to know the point of tangency, and I need to know the slope of the tangent line. The first part's a little tricky, not because it's difficult, but because the stuff they've given to you is like kind of right in front of you, right your face, and so sometimes those are the hardest things to see. So when t is 0, what's P of 0? No? 50. Now we'll get to the prime stuff in a second. So when t is 0, the amount is 50. So this right here, P of 0 equals 50. That is your point of tangency, right? That's kind of like your x and y. Technically, it's your t comma p, but it's like your x and y. So if you wanted to think of it like an x and y, I know for sure that they took that here. But that's your point of tangency. We also need to know your slope of the tangent line. That would be p prime of 0. And I believe that is -2, isn't it? Because, e to the 0 is 1 and all that stuff. So sure, -2 right there. And so you could write a tangent line equation. You could use y's and x's. I'm going to use p's and t's. So I'm going to say p minus 50 is equal to -2 times t minus 0. But like I said, if you wanted to use a y in place of p and an x in place of t, it's okay. So that's the equation of the tangent line. So then we get that. This is what this investigator is using. And then it says, at what time t does this model predict that the lake becomes safe? So what would I need to plug in to figure this out? The lake becomes safe when there's how much pollutant? 40. So what would I do with the 40 in my little linear equation? Plug it in for p, yeah. So if I said, hey, I want the level of pollutant to be 40, so it'd be 40 minus 50 equals -2t. So that would be -10 equals -2t So this guy is predicting that when t is equal to 5, the lake will become safe. Okay? According to our actual P of t model, that's not true at all. But according to this tangent line approximation, which we know is not as accurate as a curve, maybe he's saying the curve isn't accurate. I don't know. He's saying when t equals 5, that's when it's going to happen. All right. Did you guys have any follow-ups on that one? I feel like tangent lines always feel like they're out of left field. It's like, what, tangent? Ah! Remember, a tangent line is point of tangency, slope of tangent line. If you can keep those straight, I think you'll have a good shot. Any questions? Come on. Anything at all?